Good morning, everyone. This is Rick Murphy with AllNet. I'm going to be the host of the webinar today, and Paul Malizio from Archibald and Meek will be your presenter. Paul's firm is the Lutron rep for Illinois, and he helps us out here at AllNet with anything Lutron related. So once again, Paul Malizio with Archibald and Meek, and we're going to talk about Lutron today. Paul, take it away.
All right, thank you. Good morning, everybody, and thank you for taking the time to spend a little bit of time with us learning about LEDs and all the issues that they're causing you and why they're causing you those issues. With me, I also have Courtney Kent. She's new with Archibald and Meek, and she'll be transitioning into taking over the role of calling on distribution and the folks that are calling that buy through distribution. So please give me a warm welcome for Courtney, and we'll get started here. So really what we want to do today is cover just a couple of simple topics. Well, not so simple topics, but hopefully we can make them a little bit more simple. We want to understand different load types. We want to identify the challenges with those load types and then help you find the right solution. I mean, that's really what it's all about, is making sure that you and your customers are having the right experience. So with that, what you will commonly run into in the field with different types of lighting loads are incandescent, halogen, magnetic low voltage, which is kind of the old school, really heavy wired wound transformer. Most commonly you'd see this with like landscaping lighting or other types of low voltage lighting. You know, in the early stages of under cabinet lights and puck lights and those types of things, sometimes they're magnetic low voltage. But more so now than ever, electronic low voltage is the type of transformer that you'll find with those under cabinet lights, a lot of the landscaping lights now that are going to LED and things like that. ELV, or electronic low voltage transformer, is different, that they're actually a solid state device. So there's a circuit board and some other solid state devices in that actually reduce the voltage, rather than using a transformer to step the voltage down. There's a lot of pros with that, meaning that, again, they're smaller, they're lighter weight, they're usually more energy efficient. The cons are that sometimes they can be difficult to dim for various reasons. And then when you get into the LED lighting loads, you know, there's a whole different variety of LEDs. There's replacement lamps or bulbs that, you know, you would just replace a regular incandescent or halogen type of light bulb with. You also have dedicated LED fixtures. So there's more moving parts with LEDs than there are with any of the other types of lighting loads. The common types of dimming that you'll run into are triac style dimming, which is what Lutron uses, and most of the major lighting control brands these days are using triac style dimming. Joel Spira, the founder of Lutron, actually invented the first solid-state triac dimmer in his apartment in Brooklyn back in 1959. So he was kind of the pioneer when it came to solid-state lighting control. You also see pulse width modulation, which a lot of times that's going to be more into under-cabinet lighting and things like that. And from your perspective, the style of dimmer that you use doesn't necessarily have an impact on it, or should say it doesn't necessarily have an impact on the style of dimmer that you use. And then, of course, there's 0 to 10 volt control, and there's a variety of options for 0 to 10 volt controllers within the Radio RA2 family of products and within standalone wall box products. And when I say wall box, I mean kind of dumb dimmers. They're just regular dimmers not connected to any part of a system or not capable of being system integrated. So understanding the different types of LEDs and where the challenges come in is every LED, whether it's a dedicated LED fixture, whether it's an incandescent fixture that has a replacement lamp or a replacement LED fixture head in it, they all have three moving parts. There's the LED driver itself, which is kind of the brain of the system that tells the light engine what to do. Then you've got the LED module itself, which is what I'm referring to as the light engine. So that's got the actual light emitting diodes on it that's producing the light. You know, obviously there's a housing, but then you also have the type of dimming control. And all of those parts need to work together in harmony for the customer and for us to have the right dimming experience. You know, and again, I mentioned that all types of LEDs, whether they're a dedicated fixture or just a replacement light bulb or replacement lamp, they all have these same moving parts. They've got the LED module, they've got a driver, and where the challenge with a lot of the LED bulbs comes in is you're taking a driver that typically is, in a package around 4 to 5 inches long, 4 to 5 inches wide, and maybe an inch or two tall, and you're squeezing that down into the Edison base, this little screw-in base of a light bulb, and expecting that you're going to get the same performance out of that guy as you're going to get out of the brick that goes into a dedicated fixture. So with those moving parts and the fact that you're taking all of that technology and trying to shrink it into a tiny little package, what could possibly go wrong? Well, the answer that you guys all probably have experienced is a lot can go wrong. One of the challenges that you can definitely run into is, if you go to any of the box stores or even to your electrical distributor that stocks any kind of LED light bulbs, you'll see this one, it says LED dimmable BR30. Well, what does dimmable mean? Part of the problem in the industry is that there is no standardization, and anybody that makes an LED bulb can slap the label dimmable on it if it can dim to less than 100%. So what does that mean? Will this one dim down to 90% and then drop out? Will it start to flicker or buzz? We really don't know unless it's one that we've specifically tested or that Lutron has specifically tested. So that's one challenge that you'll run into. The other thing, I was kind of mentioning, it's, as far as there not being any standardization, it's kind of the Wild West out there. I mean, manufacturers are obviously in the business of making products for the least amount of money and selling them for the most amount of money. So they're trying to take all of that technology again and shrink it down into a form factor that's the most cost-effective for them. And there is no standardization around what quality standards they have to meet as far as dimming. There's no standard as to what type of dimming technology that they have to use. So it's important to look for a few things. Before we get into some of those tools that we have to help you out, I want to just kind of give a quick overview of the different types of standard dimming that you'll hear when dealing with triac style dimmers, since that's most of what you'll run into in the world these days. So you'll hear us talk about forward phase dimming and reverse phase dimming quite a bit. So in this image here, you can see that in the top graph here, you've got the forward phase dimming. And what this is illustrating is, in a triac style dimmer, instead of doing a pulse width modulation or limiting the width of the pulse waves of electricity that's coming through, what we do is we actually turn that dimmer on and off hundreds and thousands of times per minute per second. And that's how triac style dimmers end up limiting the total amount of voltage and current that goes into a fixture and effectively dimming it down. So with forward phase dimming, what we're using is the forward part of this wave. So the darkened in blue area is the forward part of that phase. That's the part of the phase that we're keeping. With the triac dimming, what we're doing is actually chopping off the back part of this wave. The more of the wave that you chop off, the dimmer the light gets. So in this case, we're basically at about a 50% dim. And with the opposite would be reverse phase dimming. In reverse phase dimming, we're using that reverse part of the phase, and we're chopping off the forward or the leading edge of that phase. Same thing on the downside of the cycle. So one of the things that you have to do right out of the gate is you need to figure out, if you're dealing with an LED, and this is more so with dedicated LEDs, what type of dimming does this type of LED prefer? Does it prefer forward phase dimming? Does it prefer reverse phase dimming? For some reason, with the electronic low voltage, almost always they prefer reverse phase dimming. I'm not 100% sure why that is. It's just the way that they use the diodes to limit the current. And that's probably about as technical as I can get with you on that one. But for some reason, electronic low voltage, because of the design, almost always prefers reverse phase dimming. So that's one thing that you want to check when you're dealing with LED fixtures is what type of phase dimming does it like, forward phase or reverse phase. This gives you a little bit more of an illustration of that triac style dimming. So up at the top here, you've got your full sine wave. This is a alternating current sine wave. And with this one, we're using this is a forward phase illustration. So we're starting to chop off the back of that wave on the positive side and on the negative side. And the further into that wave we cut in and chop it down, the dimmer the light gets. So sorry about that. So here we're at full on. Here we're probably at about 80% on. Here we're at about 50% on. Here we're probably at about 25% on, and so on. Same concept for reverse phase dimming. So different types of lighting loads. With incandescent, they're always forward phase. It's just because incandescent light bulbs are basically just a standard resistive load. Same thing with halogen, same thing with magnetic low voltage. The heavy wire wound transformers always work better with forward phase style dimming. So these are good things for you to know. So incandescent, halogen, MLV, all forward phase. When you get into ELV or electronic low voltage, again, they're almost always reverse phase. I've never actually seen one that wasn't reverse phase, although there could be some out there. And then when you get into dedicated LEDs, they could be either. They could be forward or reverse phase. So again, best thing that you can do for yourself is figure out what type of phase dimming these guys actually need when you run into them. So another issue that some people will run into is, especially when you get into the Chicago market and some of the suburbs around Chicago, it's not really common to have a neutral in every switch box. When you get into other parts of the country and really the rest of the country, Romax and VX cable are widely in use, and because of that, there's always a neutral in every box. With Chicago and a lot of the surrounding suburbs, everything is pretty much in conduit, so the electrical code currently doesn't require you to have a neutral in every box. My understanding is that the National Electric Code is changing in 2020, and it will require to have neutrals in every single switch box, but it's not that way right now. All of the dimmers have a minimum wattage requirement. So C.L dimmers would be the common go-to dimmer if there is no neutral in the box. It's just a regular 2-wire dimmer, so it's got the hot coming in and it's got a switched hot or a dimmed hot going out. And there's no neutral wire connection. So those dimmers have a 40-watt minimum required load for them to perform correctly. If they have less than that on them, they will think that they're turned off, and that's when you'll get into issues with the light dims down to like 5% and then it starts to flicker, or it buzzes a little bit, or it just, it kind of glows a little bit and never completely turns off. More times than not, that's an issue with minimum wattage requirement. So if you look at some of our other dimmers that we have the 6ND dimmer, we have the 10ND dimmer. Those guys only have a 10-watt minimum wattage requirement on them. So if you have an option of using a neutral wire dimmer, it's always best to use a neutral wire dimmer. But again, if you don't have that option, you have the 6CL dimmer that you can use for a regular 2-wire dimmer. You just have to be cautious of the minimum wattage requirements. And then if you look at the 6NA dimmer, which is our phase adaptive dimmer, it can do both forward phase and reverse phase dimming. This guy only has a 5-watt minimum wattage requirement. So what I tell a lot of dealers as I'm troubleshooting projects with them and everything is, if you're going to pick one dimmer to keep on your truck that would solve 99% of your problems, keep a 6NA on the truck. If you run into a problem switch leg, you can try throwing that 6NA in there. More times than not, it's going to fix the problem. So other things that can go wrong. This is off of a cut sheet of a Juno fixture. And if you look through some of the verbiage on here, when it gets to the point where it talks about dimming, it says 120 volt only driver is dimmable with the use of most incandescent, magnetic low voltage, and electronic low voltage wall box dimmers. So they're basically providing you no help. They're being as vague as they can and saying that, yeah, it should work with most dimmers, but good luck. So this is another thing when you're looking at the fixtures that people are using, try to get detailed cut sheets. Don't get the cut sheet that they would have on the shelf at Home Depot. Get an actual cut sheet that has all the true specs on it. And usually they'll tell you, we'll work with forward phase triac style dimmer. We'll work with reverse phase triac style dimmer. In this case here, this fixture, it says that it works with 0 to 10 volt. It also works with phase dimming Lutron dimmers. Well, again, what does that mean? They're all phase dimming. Is it forward phase or is it reverse phase? So again, what you would want to do in a case like this, if you're not sure which phase it needs, forward or reverse, use a 6NA dimmer. If at all possible, it's going to help you resolve most of your issues. You can also call the manufacturers. You can also call the manufacturer's reps. Archibald and Meek we are actually a lighting manufacturer's rep as well as a controls rep. So we've got about 60 different lines that we rep for. We can help you out in a couple of different areas. Number one is we can help you get the spec sheets on specific fixtures, very easily, obviously, if it's one of the manufacturers that we represent. We can also take a look at the cut sheets for you and give you our best educated guess as to what dimmer you're going to need for that style of fixture. But you want to try to find out as much as possible what you're dealing with as far as the phase control. So Lutron came up with several tools to help guide you through some of these issues. And at this point, I'm actually going to jump off the PowerPoint for a second here and actually take you to this lutron.com/LED. So if you do lutron.com/LED, this is the screen that it's going to take you to. There's a couple of different tools on here. One is this LED report card tool. This one is nice because if the homeowner has a specific LED lamp or a specific LED fixture, you can go into this tool and look to see if Lutron has tested it. There is a huge library of replaceable LED bulbs and dedicated fixtures that Lutron has tested. And it's actually kind of a hazing process for all the new engineers at Lutron. They put them in a room with a bunch of dimmers and they give them a bunch of LED light bulbs and they have them test them with different dimmers, and they do that for 8 hours a day, every day of the week. And if they can survive that, they get to move on and do a more exciting and fun job with Lutron. But Lutron is probably the #1 company when it comes to actually testing LED bulbs and fixtures and making sure that we can provide intelligent information to you guys out in the field as to what's going to work and what's not. The other thing that I wanted to show you here really quick is this LED bulb compatibility tool. So if you click on that, again, in a lot of cases you're going to be dealing with having to use a 6CL dimmer because there is no neutral wire option in the box. Or maybe it's a condo in the city and the conduit is just full and there's no option of pulling a neutral to that box. So you click on that tool, you click on one of two options. You can specify which dimmer you've got, or you can say, okay, well, I know I've got a specific dimmer. I'm going to pick on this and I want to try to find a dimmer. You're going to click on this wireless, this shows a picture of Caseta, but whether it's Caseta, Raw Select, or Radio Raw 2, you're using a wireless dimmer because it's part of one of our wireless lighting control families. So you'll click on that. You scroll down, and if it's a Radio Raw 2 C.L, you click on that, obviously. If it's one of the Caseta dimmers, you click on those. So in this case, I'm going to click on the Raw 2. It's going to ask you to look for the markings on here that's going to validate that it is a C.L dimmer. So we'll say, yes, my dimmer has this etching. It is a C.L dimmer. And then it's going to pull up all of the different lamps that Lutron has tested and approved as a good fit for Lutron. So in this case, you'll see there's a note here. It says this is a best dimming bulb recommended by Lutron. So Lutron has tested this, found out that it has good dimming performance, and now you know it'll work. It'll even give you the Home Depot SKU number. I was told last week by one of the sales VPs at Lutron that Home Depot actually took a stance because they got so tired of people calling them and fighting with them about compatibility issues that Home Depot going forward will no longer stock dimmable LEDs on their shelves unless they've been tested with Lutron. I'm not necessarily advocating for Home Depot. I don't own any of their stock, but if Home Depot decided to take that stance, if you're going to have customers that are going to go out without taking your advice and go find their own off-the-shelf LED replacement lamps, I would steer them towards Home Depot. Another good idea for you would be, if you're selling a Radio RA2 project or you're selling a Radio RA Select project and you're doing a $10,000 RA2 job, save yourself some headaches, go out and buy $300 or $400 worth of the LED replacement lamps that you know are going to work, and sell it as part of the package for the lighting control, and tell the customer, hey, if I'm going to do the lighting control package, you have to use the lamps that I recommend because I know that they're going to work and they're not going to cause any problems. So don't forget about using that tool. It's a really great tool. The LED report card, I'm not going to dive too much into that. What that will do is pull up a list of different LED bulbs that we've tested with different dimmers, and it'll give you a report card on that dimmer and say it has a dimming range of 100% down to 20%. And if there's other mitigating factors, it'll say, dims down to 30% and then starts to buzz a little bit before dropping out at 10%, things like that. So you can check if there are specific bulbs that you're dealing with on a project to see how they're going to actually work with the Lutron lighting control hardware. So that's one tool for you, and I would encourage you to take advantage of that. Another thing that you have available to you that not a lot of people know is that Lutron has OAM agreements with most major LED lighting manufacturers. This happens to be Contact. This is a brand that we're the reps for. They're based in Northbrook, Illinois, so they're a local company. They make a lot of great dimmable LED products that play very well with Lutron lighting control hardware. But you'll notice here, if you look in the driver selection part, you can actually order this Contact fixture with a Lutron driver in it. Most major brands, there is an option for a Lutron driver to be specified on that fixture. So one of the things that you can do, even if you're fighting the battle with the electrician and you don't want to try to steal that business away from the electrician, if you're in there on the job early enough and you can talk to the general contractor, you can talk to the electrician, you can talk to the architect, you can educate them, let them know that, hey, that's great. You want to use a Juno 4-inch downlight? Knock yourself out, but please spec it with a Lutron high-lume driver. That way you know that the high-lume driver is a Lutron product. It's going to work with the dimmers that you're specifying. That way you're not fighting with the electrician, you're covering your own butt, and you're providing value to the architect and the GC because you're helping them avoid future issues down the road. Another option that you have here when you're dealing especially with the C.L dimmers where a lot of people will have problems with the minimum load requirements. For example, at my house, I have a porch light and then I've got a couple of coach lights. That porch light is the only one on the dimmer, and I have no neutral in that box, so I had to use a C.L dimmer. So what you can do is there's this device, this LUT-MLC. It's basically just a little package. It's a little bit bigger than the size of a chiclet. So it's pretty small. It's basically an artificial load, so it's a capacitive artificial load that tricks the dimmer into thinking that there's more of a load on that circuit. So if you have an issue where you have 1 or 2 or even 3 LED replacement lamps on a circuit and you're using the C.L dimmers, if you're getting that issue with flickering or they won't quite shut off all the way, get some of these LUT MLCs. I would recommend these are another piece. Carry them on your truck because at some point you're going to run into this issue. In the packaging with it, it gives you a little wiring diagram, and it shows you here that it is actually in parallel with the lighting load, not in series with it. That's an important thing when you wire it in there. You have to wire it the right way or it's not going to do anything. It won't do any damage, but it's not going to help solve your problem. So here's typical installation of dimmers, regular 2-wire dimmers that have 3-way applications. You'll notice you can put the regular dimmer in any one of those locations. This is a 4-way switch location. Same thing if it's a three-way. You can put the main dimmer in any one of those locations, and the remote dimmers can go in any of the other locations, and everything is fine. What you'll find out, though, is a lot of times if you're using neutral wire dimmers, you'll end up having issues where there's flickering or buzzing, or the LEDs won't quite turn on all the way, or they'll turn on and turn off and turn on and turn off. The issue with that is that if you're using neutral wire dimmers, the neutral wire dimmer, the actual dimmer, not the remote, has to be on the load side. So another thing to check, if you say, okay, well, I'm using neutral wire dimmers, I don't have this minimum load requirement, but I'm still having issues, this is something for you to check, to troubleshoot. You want to make sure that the main dimmer is on the load side. And you can see from this drawing what that means. Again, with any of these things, if you have questions, obviously answer those questions. If you think of questions down the road, I'll show my email address again. I'll answer questions for you. I cover Chicago and Central Illinois, but if you happen to be in Wisconsin or Michigan or one of the other areas that AllNet supports, if you shoot me an email, I'm not going to say, hey, I'm not your rep, I'm not answering this question for you. Send me your questions, I'll help you out, and I'll get you in touch with your local rep so that in the future you have a connection with somebody local that can help you out. So here's the different types of dimmers that we've got in the RA2 family of products, which most of you guys are selling. So again, I mentioned the C.L. It'll show you, and it'll even tell you on the spec sheets. If you pull up the product specification submittal for the dimmers, it'll tell you what type of lighting loads they're approved for. So the C.L dimmer, again, is just a 2-wire dimmer. It's meant for forward phase dimming, but it will work with a lot of the replacement LED lamps. The 10D is a regular 2-wire dimmer that's capable of handling up to 1,000 watts. This guy is really not going to help you when it comes to dimming LEDs. The 10ND, again, is going to do, it's got that neutral wire, so it's going to have a lower minimum wattage requirement. It's going to work for a lot of LEDs. We just came out with, Lutron just launched the RRD-6ND, so it is a 600 watt for incandescent neutral wire dimmer. It's only $139 retail, so it is actually the least expensive dimmer in the family. When you're dealing with dedicated LED fixtures, this guy will work in most of your applications unless it specifically calls out that it requires reverse phase dimming. So from a cost-saving standpoint, if you're engineering a job, if you have a neutral wire option, you can go with this 6ND. It's going to save you some money, and it's going to get the job done for you. Lastly, I talked about the 6NA. So this guy is a phase-adaptive dimmer. It will work with forward phase and reverse phase. Pretty much anything you throw at this guy, as long as it truly is a dimmable LED, this guy can handle. There are a couple of tricks with this that you'll sometimes run into. In the RA Select and the Caseta app now, you can actually set your phases with these 6NA dimmers just like you can in the RA2 programming software. So what I mean by that is if you are not sure what type of dimming load that LED requires, you throw a 6NA dimmer in there. More times than not, I would say probably a good 90% plus, that dimmer will figure out, because it's phase adaptive, it'll figure out what type of lighting load is on there and what type of dimming style it prefers, whether it's forward phase or reverse phase. Sometimes it will get confused, depending on the quality of the LED fixture itself and the quality of the driver, it may not be able to figure out. So one thing that you can do, if you're having an issue with the 6NA, you're using the neutral wire dimmer, it's got the lowest wattage capacity, it's phase adaptive, so you've got the best guy for the job, it just still doesn't seem to be working. One of the things that you can do is either go into the app or go into the RA2 programming software and set it as a forward phase dimmer. Try that. If that doesn't work, manually set it as a reverse phase dimmer. Again, if you have questions on this and you want to give me a call later, I can walk you through the process either in the software or in the app to do that. And since I'm mentioning that, you can also set the trim in the app now. This is a new feature that you guys may not have noticed in there. So in the Caseta app, the RA Select, and even the Connect app for Radio RA2, if you're having an issue where a dimmer, it dims down to about 10% and then it'll either drop out or it'll start to flicker or buzz, you can go into the app, you can pull up that dimmer and edit that dimmer, and you can set either a high-end or a low-end trim for it. The low-end trim would be, again, you're having a problem once you get down to about 10%, so you can set the low-end trim on that dimmer to 10%, so when you push the dimming button on it to dim that all the way down, it'll only dim that fixture or that bulb down to 10%, and that's the max at the bottom. The high-end trim you can set if you've got a really bright LED and you don't necessarily need the entire lumen output of it. You can set the high-end trim so that when you turn it on, it only comes on to 90% or 80% or something like that. But check out that new feature in the app. That'll save you some headaches there too. When you get into under cabinet lights, puck lights, tape lights, those sorts of things, you're going to get a mixed bag, again, with the quality of the LED drivers that come along with them. I don't want to turn this whole thing into a Lutron commercial, but I did want to make you aware Lutron does make drivers for LED tape lights, for rope lights, for puck lights, stuff like that. We have a variety of different drivers. This guy here, the High-Lume Premier, can handle up to 96 watts of LED. So typical tape light, you're talking about maybe 3 to 5 watts per linear foot. So you can, in a case like that, you could cover a pretty sizable kitchen with one driver. There are other ones. This guy will dim down to 1% with most tape light. There is another driver that will only dim down to 5%. It's a lot less expensive, but it can only handle up to 40 watts. So just know that if you're looking at tape lights or under cabinet lights, things like that, if you're having issues dimming the driver that they've got, you might have the option of swapping it out for a Lutron driver. These drivers you can purchase through AllNet. It's not something that they would have stocked on the shelf. They can custom order it. It is a stock item at Lutron, so it would ship out quickly. But I just wanted you to know that is an option. And again, we rep other lighting manufacturers, so we have access to other tape lights that you can use Lutron drivers with, or that we know work well with Lutron drivers, so I can help you out in that regard as well. Here's some other tools for you that you can take advantage of. If you go onto the LCI Online, so if any of you have gone on and done the Radio Raw 2 certification training or shade training, you've got an LCI Online account. You can go on there. There's a couple of different training modules that you can take. This understanding load types, if you want more detail on the load types I was talking about, you can find it in that training course. There are about 15-minute training modules. They're broken up into little 2 to 3 minute videos to cover different subjects. So they're really, you can jump in and out of the training if you want to learn about one specific thing and then you run out of time and you want to come back later. So they're really great tools for you to educate yourself on LEDs and what some of these issues are and how to mitigate those problems. Introduction to LEDs and LED drivers. The Radio Raw 2 Level 1 qualification course, we do talk about LED drivers and issues in there as well. If you go onto the Lutron.com website, there's also a series of different app notes, white papers, and different technical documents that you have access to. So again, if you want to just learn more about LEDs and you seem to be running into certain issues, you can go on here and educate yourself and more on that. If you have any trouble finding any of those links, just shoot me an email and I can send you a link to those directly. So hopefully that gives you a little bit of a baseline for what some of the issues with LEDs are and have given you some tools to help mitigate some of those problems that you're going to definitely run into. LEDs are becoming more and more of a standard, and as much as I don't like it personally, we're all going to be forced to switch to LED at some point. So best to get your head wrapped around how to work with them and how to mitigate some of those issues and figure out how to solve them up front.
Well, Paul, once again, thanks for all the support you've given us. Everyone, if you have any questions, please feel free to reach out to Paul. His contact info is on the screen, or you're welcome to reach out to any of us at any of the AllNet branches. We're all very well-versed on Lutron, and we're happy to help. So with that, we're going to go ahead and wrap up the call. Thank you, everyone, for your time today.
Thank you.